Hello everyone. Welcome to the video series on Introduction to Machine Learning with Scikit Learn. This is part 3 of chapter 6, and in this particular chapter we will see what is data normalization. This is also the last chapter of linear regression. If you haven't seen my earlier chapters on linear regression, I will highly recommend you to go ahead and look into the same. Now let's understand what is data normalization. Before we proceed, let's understand one thing, that data normalization is applicable to all the machine learning algorithms. It's not necessary to use it only with linear regression. We can use the same with any other machine learning algorithm. Before I tell you what data normalization does, let's first try to understand what is the problem it's trying to solve. To understand the problem properly, I have come up with one example. Let's consider the price of 1000 square feet land at different locations from the downtown. At downtown, the same thing costs $200,000, in city 175, outskirts 127, town 85, village 59, and farm $43,000. Let me represent these data as x and y using NumPy array. So I'm representing distance as well as property price using NumPy array. I am doing reshape so that I can convert this into a column vectors. Okay, you remember from my earlier videos that in machine learning we use column vectors, not the row vectors. Now let's plot the same. Here is how the plot looks like. Okay, nothing great about it. Now let's go ahead and do a simple exercise. What I want you to do is that use the scikit-learn linear regression algorithm and print the following for this x and y data: mean square error, slope, and intercept. I have already told you how to do the same in chapter 6.1. Okay, so I will highly recommend you to pause this video, do this exercise, then come back again. And this is where I have kept the code. I will provide the same in my GitHub page when I upload this particular content. And here is how the program looks like. I created the instance of linear regression. I call the fit function by passing x and y values. And for the prediction, I am calling the predict function by passing the distance. Okay. And mean square error is calculated here by comparing actual price and the price that is being predicted by my linear regression algorithm. And I am printing slope and intercept. So if I go ahead and do that, you can see that there are some big numbers that comes as part of this. For example, mean square error is 24775766, so does slope and intercept -1382 and 1888573. Okay. Now when I go ahead and try to print the prediction thing, here is how it looks like. I'm sorry guys, it looks like in predict E is missing. Sorry for my spelling mistake. Now here is how it looks like. For $200,000 it gives me 188, for 43 it gives me 22. So not as great as I have expected, but this is the output which I get. And here is my property prices, actual property prices. And if I go ahead and plot the data with actual and predicted property prices, you can see that this is my actual and this is predicted. And obviously it looks like the mean square error will be large because there is a deviation. Now when I say mean square error is large value, do you see a problem in here? Mean square error, slope, and even intercept are big values, may lead to integer capacity. Yes. So as of now, I'm just talking about $100,000, $200,000. What if we are talking about millions? What if we are calculating something related to population of a country and something similar to that, or population of a planet? When you calculate mean square error, it's highly likely that an integer overflow can happen. Okay, based on the nature of these calculations. So you will get an error and your machine learning will stop in between. To avoid these problems, we use data normalization. I hope you understand why we use data normalization. Now, how do we do data normalization? It's very easy to do it with scikit-learn because scikit-learn provides all the mechanisms needed to do the data normalization. In this particular case, we need to use min-max scalar from scikit-learn preprocessing, create the instance of min-max scalar, and what we will do is that we will call a function called fit transform, and we fit transform y property price to get new property price. Okay. And here is how our new property prices will look like. So you can see that the highest value converts to 1 and lowest value converts to 0. Okay, so what data normalization does is that no matter what your value range is, it converts everything into a range from 0 to 1. Okay, now we'll do the same for let's say this distance from downtown, And here is how we get the distance. So lowest is 0, highest is 1. Okay. Now let's plot the same using the matplotlib. You will not see any difference in the way a graph is plotted because it doesn't change the data, it just normalizes the data. Now let's go ahead and call the linear regression on the normalized data. I did the same thing, pass the fit function, pass the predict, and let's see how it looks like. So mean square error is now a smaller value called 0.0100. Slope and intercept is minus 1 point something and 0 point something. If you go ahead and see how our prediction looks like, you will see, this is not what we wanted to predict, right? We wanted to predict in prices in USD, right? So how to convert this thing into the actual prices? Not to worry, the min-max scaler provides a function called inverse transform. Okay, what inverse transform does is that it takes the value, normalized value, and gives you the actual value. What we do is that we will call inverse transform with the price predict, and here is how it looks like. It converts the these decimal value into the original value, and you can see that the prediction is absolutely same, 188.22.658. If we go ahead and see what we got from our earlier thing is that 188.226, it's exactly the same. Now you understood why we should use data normalization. Okay, same thing we can do for even distance also to get the original values. Now that's all for this particular video, but I want you to do one exercise. What I want you to do is that use the y equal to mx plus b formula which we have used in chapter 6.2 and calculate the mean square error. You have to use the mathematics to calculate the mean square error, and I have already provided the solution over here, but I want you to do it. I'll upload the solution when I will upload this particular Jupyter notebook in my GitHub page. Okay, so that's all about linear regression series. We talked about what is linear regression, we talked about maths behind linear regression, and we talked about data normalization. Okay, and data normalization is applicable for all other algorithms, not only to linear regression. So that's all for this particular video, guys. We'll see with some other algorithm in the next video. Thanks a lot. Thanks for watching. Please take a moment to like, comment, share, and subscribe. Thank you. Thanks a lot. Good day.